Okay, welcome to our discussion of research methods. Um, and I have one of my favorite Far Side cartoons here. I always like to start out with some humor. Let us move on to talking a little bit about how psychologists come up with their findings. First, before we get into that, let's define what psychology is. So you could say that psychology is the scientific study of behavior and the mind. And there's three things that I like to emphasize about that definition. First, it's a very broad definition, so it encompasses lots of variations of studying the way that different people can define psychology. But there are three things in that definition that I think are important. One is the word scientific. And by that we mean that psychology uses the scientific method just like any other field. So scientific method is a way of understanding nature. So it has certain principles that are agreed upon, like things like standardization and control and replication and other things like that we'll talk about a little later. So it's a science just like any other science, and it's important to note that. The other thing is behavior. When we're talking about behavior, we're referring to, traditionally in psychology, we're referring to observable behavior, and that's an important distinction. There have been discussions in the past about what is behavior. Are certain things like language, would that constitute behavior? Other things that are not observable, but would we count that as behavior, like introspection or thought, and so on. So we'll talk about that with respect to primarily the behaviorism school of thought. And then the scientific study of behavior and the mind. So with regard to the mind, what we're talking about is really all the other aspects of psychology that that have been discussed besides observable behavior. So these would be things like consciousness, the self, things like that, the more cognitive approaches. And again, we'll get into that. But that definition, like I said, is a very broad definition. It encompasses really a lot of the way that we approach psychology today. So now, as if you've been looking on your screen, we've got this nice little sort of flow chart that sort of talks about how researchers start with, in any experiment, a theory, right? And so let's talk a little bit about this. Basically, so if you start with a theory right at the top here, and we'll talk about these different terms in a little bit. You start with a theory, like you could have a theory that says that what happens to things when you drop them, right? Those would be a theory of gravity, right? So you start with this broad theory, and then from that theory, right, if you follow that down, you can get a prediction, right? So your prediction from that, theory would say, if you have a theory of gravity, your prediction would be things fall to the ground, right? So that's your prediction. And then go down further, right, carry observation, do an experiment to test that hypothesis, that prediction. And so you take some kind of object, lift it, hold it up, drop it, and does it fall to the ground? If yes, right, then on the very bottom, do we need to refine the theory, or is the theory maybe strengthened? And if it's strengthened, if we keep getting in the affirmative, we might say that theory then is very robust and accurately defines or describes the state of nature with respect to that phenomenon. But if we get differing findings all the time, right on the very bottom there, then it turns out we might need to tweak the theory, change the theory, modify it. And so when you modify it, right, then that'll, of course, give you different predictions, and you go back and retest those. And so that's what we refer to, generally speaking, as the self-correcting nature of science, right? That with something like this, good theories will keep being supported by the data, and theories that aren't very good or aren't very helpful will not be supported by the data. Okay, so let's talk about a little bit about these different approaches to doing research. Right, we've got descriptive, correlational, experimental, and we'll talk a little bit about that as we go on in the lecture and also through the whole course. Now, descriptive, as you can see, is just basically, what are you seeing? You're describing something, right? So things like case studies, you can see naturalistic observation. You're not manipulating anything as the researcher. So it's not an experiment. Now, correlational studies would be things like you're trying to find the definition of a correlation, right? And we'll come back to this. But it's the naturally occurring relationship between any two variables. So you want to find out if you have the presence of something, does something else usually co-occur? Those things would correlate or co-occur. So things like statistics, other types of observation. And again, you're not manipulating anything. Like, for example, here's a correlation based on a stereotype. Every time you see a person with blonde hair, does it look like they're having more fun than people with brunette hair? Right? It's a co-occurring relationship, right? The amount of fun you're having and the color of your hair, right? And we can test that to see if that's accurately describing the state of nature. Then next, and the last, and one we'll talk about the most, is experimental research methods, right? Where the goal is to understand cause and effect. If I have a presence of variable A, does that cause people to behave in a certain way, right? Some kind of, right? For example, if you're happy and you know it, do you then always tend to clap your hands, right? Maybe. And some of you will get that joke. But for example, the influence of, let's say, heat on agitation or irritation or maybe even anger, right? So we can look at the influence of that variable on that type of mood state, and you would assign people to different conditions and different types of exposure to different levels of that variable, and then see. So you're manipulating the independent variable here that we're manipulating is temperature of the room. And so some people will get one temperature, some people will get a different temperature, and so on. And we want to see if it affects their anger level or irritation level. And there's ways to measure that too. Right? So that would be a nice way of understanding cause and effect with regard to the influence of heat, or just sort of, generally heat on someone's mood. Okay, so we'll come back to, and we'll again explore that in a lot more detail, because that's the goal really of any science, is to understand cause and effect. Okay. I think I'm going to skip through this. This is further description of descriptive studies, so we're going to skip past this here. And let's talk a little bit about now some distinction between lab and field research. Now, field research is basically anything that's not done in the lab, right? So field research is things like there are surveys, could be archival data, anything that's not done in a lab. You could reanalyze other people's data, and also, right, of course, anything that's out in the quote-unquote real world. If you do a study looking at people's behavior out in the real world, like at a shopping mall, for example. That would be considered field research. So the great advantage of field research is that people don't know they're being studied. So, for example, let's take the example of going to the mall, right? And you're sitting there on the bench watching people's behavior, some kind of behavior, and they don't know that they're being studied. So and the reason why it's great is that they then will just be doing their natural, normal behavior, which is what we want, right? The disadvantage is that you don't have control over the environment. So there could be other, what we call confounds or unwanted variables that might be happening that could affect their behavior that we're not really wanting to affect their behavior. And that could be at play, and that would interfere with our ability to establish cause and effect. So that's a problem. And so really, with field research, the best we could get is to establish correlations. And that probably is another disadvantage, right? Is that you can't establish cause and effect. So again, with correlations, all you can understand is what variables co-occur, or what are the naturally occurring relationships between any two variables, right? And I just want to put this up here with regard to correlations further, to further sort of talk about this important point. We've got some correlations up here. There's correlations between education and earnings, right? There's a positive correlation. The type of child rearing style, child's traits, self-esteem, and academic achievements. Now, let's go with education and earnings. More education generally means greater earnings, in terms of your wages. And so that's a positive correlation. And so, but we don't know, but could it mean that, is there a possibility that there's any other cause effect, like having a lot more earnings causes you to want to get higher education or something like that? Does it work the other way? For example, if you're looking on here on this slide, child's traits, having child's traits, does that dictate the type of child rearing style that the parent will use, or does the parent's style of child rearing dictate what kind of traits the child will develop? It's interesting. Could go either way, maybe, right? Does self-esteem predict academic achievement, or the other way around, right? If you achieve a lot, does that lend you to have higher self-esteem? Or if you have self-esteem that's already very high, does that make you tend to want to achieve more, right? And establish a higher achievement? So we don't know which of those it is. And that's what I'm pointing to down here on the bottom here, if we want to direct your attention there to that. For any correlation, we know that there are 3 possible explanations, but we don't know which one it is until we do an experiment, right? So it's an important point to remember. So if I know that, for example, there is a strong positive correlation between ice cream sales, right, and domestic, and well, it's not limited to domestic, but just say physical violence. And that's true. That's actual strong correlation. There is a strong correlation between those two things. And you're saying to yourself, what? This is kind of weird. If we look on the bottom, let's say X is ice cream sales and Y is violence. Does that mean that eating a lot of ice cream causes you to want to beat someone up? Or does beating someone up, if we go to the second observation, the second explanation there, beating someone up, and then you say, you know what, I really feel like I would like to have some Rocky Road ice cream right now, right? Or some mint chocolate chip. That sounds really good right now. Or is there a third explanation for that correlation, which might be, and some of you already have this in your mind, summer. right? Summer, if you look on this third explanation, Z would be our this other variable, which drives the increase of ice cream sales and also violence, physical violence, and right, it causes both of those to increase, and that is summer, right? Or just you could say just hot temperatures. Both of those go up in summer, right? And but what happens is that then you get what we call an artificial correlation, those little red dots there between X and Y on that third explanation. So they're artificially correlated, right? And so if we take the influence of Z out, we can do that statistically, then basically the relationship between that artificial correlation between summer or between ice cream sales and physical violence disappears, because of course it doesn't make any sense that they would be related if not for the being connected through summer, the heat. Right, so again, for any correlation, you don't know which one of these three possible explanations is true until you do an experiment. Now, another aspect of correlations that's important to note is that there are three types of correlations: positive, negative, and zero, right? So now let's go with positive. As you can see on the left, and the examples here are pretty good examples, right? Acts of aggression on the y-axis and exposure to violent TV on the x-axis there. So more exposure to violent TV, right? Watching more violent programs tends to lead people to be more physically violent in their own behavior. And there's a positive correlation, right? That means that positive correlation means that increase in one variable is related to an increase in the other variable. Here we're talking about watching violent TV, right? Is associated with an increase in acts of aggression. Now, negative correlation means a decrease in one variable is related to an increase in the other variable. Right? So, for example, here they're showing optimism scores, right? And this is illness, which is kind of a goofy thing here, but basically they're showing. If you can kind of look at this. Decrease in optimism, right? So if you're looking on the x-axis, you're going to this left here. That means your optimism is decreasing. And if you look what happens, you tend to be that leads to more illness, right? Decrease in optimism is associated with greater illness. And there's a lot of research out there on that too. Then zero correlation just means there's no regular relationship between the two variables. There's no structured or any kind of relationship between the two. Okay. Now let's talk a little bit about lab research. About 2/3 of all research in psychology is done in the lab, and the main reason is, right, that you can predict cause and effect. So we've got another one of my awesome Far Sides, right? They're doing experiments on the merits of cardboard armor. Very short-lived experiments. Now, we talked a little bit earlier about some of these terms I want to come back to. Theory, right? This is an organized set of principles that explains and predicts some phenomenon. A theory, right? So you could have, like I was saying earlier, a theory about how things fall to the ground, or psychologically speaking, we could have a theory about how people resolve psychological conflicts in the way that they think and behave. For example, smoking, right? But they know that it's going to hurt them, but they smoke anyway. How do they resolve those conflicts? And there's a theory called the cognitive dissonance theory that will talk about how people do that. But you have to start with a good theory. That's the basis for any good experiment. Okay. From the theory, you get your predictions, right? So from the theory, the theory will tell you what to predict in a given situation or circumstance. And so these are another way of saying hypothesis is it's a testable prediction. Okay. And then when you're getting your experiment together, you have to define, right? Your operational definition is the actual way that you're defining the concepts in your experiment. Let's say you're looking at the difference between depressed and non-depressed people. Right? You've got a theory about how people behave, how depressed people behave, and how non-depressed. So one of the first questions that other researchers are going to ask you is, how are you defining and measuring depression? Lots of ways to do that. Right? You couldn't say this like, oh, I'm just going to look at them and see whether or not they look depressed. Well, that's very not scientific, right? Can't do that. But if you said, I'm going to give all of our subjects the Beck Depression Inventory, and which is the most popular measure of depression, and it's got great reliability and validity, and it's been psychometric qualities are awesome. And you further say that scores on the Beck Depression Inventory of 20, let's say 23 and higher, we're going to call depressed, and scores of 15 and lower we'll call non-depressed. Okay, and so that's really specific, and that's exactly what you want to do, right? That's your operational definition. So for what I'm saying is, for my experiment, this is how we're going to define depression, right? Another researcher, in a different lab might use a different measure, might have a different way of defining depressed versus non-depressed. That's fine. But I'm saying for my experiment, if you want to try and replicate my experiment or want to try and redo it and see if you get the same results, then you have to follow my recipe, right? This is the recipe, and this is and use my measure and my cutoffs for the scores. Now, when you're doing an experiment, you're looking at the effects of a variable A on variable B, right? You're looking at cause effect. And so the thing that you're trying to look at the effects of A, right? A would be our independent variable. And this is the thing that the researcher can manipulate, the thing that I, as an experimenter, can manipulate. So, for example, if I'm looking at the effects of mood on self-esteem, let's say. So what I'm predicting is that if I put you in a certain mood, if you come to my lab and you do my experiment, I put you in a certain mood, and there's different ways to do that, then it's going to have a certain effect on your self-esteem. I'm going to give you a self-esteem measure at the end, and we're going to say maybe you're going to tend to be feel great about yourself or feel less great based on what I did, right? What the thing that I manipulated, which was your mood. If you're wondering about mood manipulations, there's ways that you can do that. Like, in the past, people have used different types of music to put people in certain moods. That's not really that reliable because people react to music differently, generally, right? They've shown people clips of movies or TV shows to try to put them in a certain mood. That also is kind of not really the best. One thing that seems to work well is to have people write for, like, say, 10 minutes in great detail about, so for example, an incident in your past that, if you want to make people sad, that was the saddest thing that ever happened to you, and write about it in great detail. And what happens is people kind of get back into that mood a little bit, some more than others, but it works well because it hits each person, right? They know what made them sad, and so you get a lot of more success in terms of mood manipulation. And the mood manipulation works fairly temporarily, about 20 minutes, which is all really you need for an experiment. And then there's ways to bring people back out of the mood, and it's not like you send them into a horrible depression. If you're making them angry, you make it all ragey. It's not that strong of a manipulation, but it's strong enough for our purposes. Okay. So again, IV is the thing that the experimenter manipulates. Now, for example, if I want to look at the differences between men and women on some variable, let's say self-esteem, that is a problem, right? I can't, if you come to my lab, I can't assign you to be male or female. You already are. So there are things, those are called subject variables. Those are things about you that I have no control over. I can't change, right? So subject variables are not independent variables. Right? A subject variable is something about the person, the subject, that the researcher cannot change, like gender, age, race, things like that. Okay, so that's a important thing to note. Okay, let's go on, and of course the DV, right, dependent variable, is the thing that I'm measuring. Right, so if we're following my earlier example, I think it was the effects of mood on self-esteem, then the thing that I'm measuring is self-esteem. Right, so the dependent variable is what I'm measuring, self-esteem in this case. In a lab, the great thing about lab research is that you have great control over the situation. You're holding, and in terms of scientific method, right, you want to hold all the variables constant. You want everybody to be exposed to the stimuli, to the environment, the same. And the only thing that's different is the level of the IV that they're exposed to. Right? So some people get, angry mood manipulation, some get sad mood manipulation, some get happy mood manipulation. Right? And that's the only thing that's different between subjects. Everything else is the same. You could have this, if you want to really be specific, same experimenter. They're all, we do things in the same order. We say the same things to all the subjects. It's in the same lab room, maybe even at the same time of the day, and so on. So everything is constant, holding control over everything. And the reason why that's important is because then like I said, the only thing that's different between these conditions, right, is the mood. And so when you look at the differences on the DVs in those three conditions, let's say happy, sad, angry, if there are differences between those three groups on the self-esteem measure, what we can say then is everything else being held constant, the only thing that was different was the mood. Therefore, we're going to say mood causes, right, this change in self-esteem. That we have this nice cause-effect relationship. Now, if we didn't have control over the lab room and other things were allowed to vary, and we did it at different times with different researchers, different times, and there's other variables that are left to kind of vary. Those would be, like I said earlier, called confounds, and those things might be the things that affect the DV. And therefore, we don't know what's causing the change, differences in the DV. Is it those other variables, or is it the mood? And we don't know. So that experiment is pretty much, wrecked. So you have to go back to the drawing board and redo it. Now, the population is the group of people that you want to generalize your results to, right? I mean, ideally, it would be awesome to be able to say, my experiment is generalizable to the whole population of the whole Earth. But we can't do that, and that's never going to be true for anyone. Not, anywhere. Not at Harvard, not at Stanford, not anywhere, not at Cal State Stanislaus. And the reason is because, of course, there's huge cultural differences. And so for our purposes here in the U.S., we will say that our population would be people in the U.S., right? So that's generally what we're restricted to. Now, the sample is the group of people from the population that come to do your experiment, right? So out of the 310 million people in the U.S., we're going to have maybe 100 people come to do our experiments here at CSUS in Turlock. right? And so the sample is taken, again, people from the population actually do your experiments. Now the sample is randomly selected. Now what does that mean? That means that everyone in the population has an equal chance of being selected for your study. Now, if you think about that definition, right? Everyone in the population has an equal chance of being selected for your study. That's never true, but that is an ideal to which we aspire, right? It's the ideal to which we're aspiring. And again, it's never true for really any researcher. So, because think about what that would entail. That would entail that we have access to every person in the U.S. Every person in the U.S. People in hospitals, babies, people in nursing homes, and people who are homeless, and so on. We know where everyone is, and we have full access to them, and we can bring them, any of them, into our lab. And of course, that just never doesn't happen. But what we want to try and do is get as close to that ideal as we possibly can. And really, if it comes down to it, that's one of our sort of areas where most researchers sort of fail in that, because what researchers usually do is just simply kind of fudge a little bit on that. They'll just select people from their intro psych classes on their campus, right? And that is not in any way representative of the entire U.S. population, right? And so critics have rightly said, well, this is, they sort of said psychology is just the study of the intro psych student, right? And kind of in some ways that's accurate, but we'll talk about that a little later. So psychologists will say, well, that's not really valid, and but there is an argument to be made for that's that we don't do as much as we should to be truly random. Okay, now once that sample comes to your lab, right, the 100 people that I mentioned, or however many people you have, the sample from the population, you've randomly selected them. They come to your lab, they're standing at your lab door, and now you have to decide what experiment condition are they going to be in. Maybe condition, A, B, C, like let's say with our mood and self-esteem experiment. Are they going to be in the happy mood or the sad mood or the angry mood? Random assignment means every person in the sample has an equal chance of being in any of your experiment conditions. So random assignment would mean that someone coming into my labs, they could be in experiment A, B, or C equally. And so non-random, for example, would be I'm going to put all the women in condition A, and all the men in condition B and C, right? And let's say condition A is happy, and let's just say I don't want to hurt any of the women's feelings or make them angry. I don't want them all to be happy, right? For whatever reason. Well, that's not scientific, and you're going to get terrible data from that, right? So, to randomly assign, you can do something like flipping a coin. You could have a statistics book in the back. There's a random number table, and have some rule about closing your eyes and touching and hitting a particular number right on the back of that on that random number table, and that would correspond to some condition. Something like that, just simple way of randomly assigning people would work. Now, how do we actually do lab research? Well, there's an old saying in psych, well, maybe the social research in general. If you want to know what someone's thinking or feeling, you just ask them, right? So, because people can tell you. So, for data collection, the most popular way of getting that kind of information is self-report questionnaires, meaning you give a questionnaire to the person, the subject, and he or she fills it out and then gives it back to you. They say, how are you feeling? What is your attitude about this? Blah, 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 blah. And then they fill it out and give it back to you. Now, and these are great because they give us a lot of data. We can give it out to huge classes, huge amounts of, people, and get a lot of data really quick and very cheap, right? Or free, essentially. I mean, aside from the costs of, making copies of the questionnaires and so on. Or if you could do it free if you had it if it was an online thing, right? Even better. One of the problems with self-report measures, though, is that people sometimes are unwilling or unable to say what they really think, right? They might try to be politically correct, give you the answer that they think you're looking for. And so one way to get around that is to tell them there's no right or wrong answer. Don't write your name down on this. We don't want to know, who said what. Just go ahead and tell us how you honestly feel. And then people usually are able to then, be honest and tell you what they think. Now, observational methods are good, except they are time intensive, labor intensive. What this entails is you could do this out in the real world, right? Observation, like going to a mall, watching people behave. Or you could have people come to the lab and you could look at them through a one-way mirror, right? And, like you've seen in cop shows and where you're looking through at the person in the interrogation room. And watch people behave with others, for example, with their spouses or children and so on. Takes a lot more time, but you can get some good data. Now, one of the problems, of course, with lab research in general, and we'll come back to talking about this again, is that people know they're in an experiment. And so you've got this issue of the artificiality of the lab. Critics will say, well, people, because they know their experiment, they're not behaving naturally. And so the behavior that you're observing is kind of, non-natural, kind of artificial, and therefore can only be generalized to that room. Right? It doesn't in any way describe real world behavior. And we will talk about at the end of this lecture ways that psychologists have tried to deal with that criticism. Okay, and now reaction time. Now, reaction time is a good way of assessing some types of behavior in that it doesn't give the person a chance to be politically correct in their answers. They don't have time to edit their responses. Because the goal with reaction time is usually like a computer screen type of program. Some word or stimulus will flash on the screen, and your job is to hit a particular key as fast as possible. And then from their reactions, right, depending on how fast they hit the keys, we can derive some conclusions about what's going on in their mind. And some fascinating research with that. And like I said, for example, I'll just briefly mention it's been used with looking at prejudice, for example. You'd have like a prime word like the word old, right? And then you'd have words that flash up that are either noun-words, positive words like traits, like friendly and intelligent, and then maybe some negative traits also, right? Slow, confused, whatever. And you want to see basically, based on the prime word, the main word that flashed up, that was there, you have that's the first word that they saw. And it was, let's say it sits on the screen for 10 seconds. Then all the other words are the words that you have to respond as fast as possible to. So they're on for fractions of a second. What we're talking about here is the anchor word, the prime word, right? What does that prime in the person's mind? What words are most related to the word old? If they're prejudiced against old people, we're going to say that they're going to be able to recognize usually mostly negative traits when those flash up, right? They're going to hit the yes key faster to those words than to positive words. And that seems to be the case. And you can do that for pretty much any other type of group. So, like I said, it's very fascinating. One caveat, though, I should say about that kind of research is that, and that task, if you're wondering, it's called a lexical decision task. That's the general name for this setup. Is that with regard to prejudice, are you in this kind of setup, are you tapping into the person's knowledge of the stereotype, or whether or not they actually believe and endorse the stereotype? Right? We all know what the stereotypes are about all various groups, but it doesn't mean that you actually believe them, right, in your heart, personally. So there's a big difference. And that's a bit of a controversy that is out there on that with regard to that particular line of research. Okay, so let's talk about how we evaluate lab research. How do you know if an experiment is good? Okay, so first, construct validity deals with this issue of, are you measuring what you think you're measuring? Are you measuring what you think you're measuring? For example, if I am looking at, let's say, friendliness, and I'm going to say I'm going to measure friendliness by how much a person's foot shakes in 1 minute, right? Does it have good construct validity? Probably not. Doesn't make any sense that a foot shaking would be related to how friendly you are. But for some reason, I think it is, right? So then, I do my experiment and don't get anything, and say, oh, that's a bummer. So we have to make sure that what we're measuring is and manipulating is what we think we're measuring and manipulating, right? Good construct validity. Now, criterion validity is where you are sort of the degree to which your a variable that you're measuring can predict future behavior in some future setting. It's the degree to which the thing that you're measuring can predict future behavior in a future setting. Like, for example, let's say I'm going to measure your ability to do basic geometry and algebra and some vocabulary words, understanding of vocabulary. And so I'm measuring all that in you. And I'm going to, based on how well you do, I'm going to say that is strongly related to or predictive of your ability to do well in, let's say in the case of college, right, like with the SAT, and in a little bit along the same lines, right, the same kind of basic principle applied to the GRE, the graduate record exam, right, for going on to graduate school. Right, so it's the idea that these scores on the things that we're measuring, right, in those abilities, are related to or predictive of how well you're going to do generally in graduate school or college. Convergent validity is this idea that it's the degree to which measures of a concept all correlate on a similar finding. Right, let's say that I have come up with a Nelson measure of depression, and I want to know, is this a good measure? So what I'll do is I'll take a whole bunch of other well-established measures of depression, and I'll have them all sort of laid out, and then and let's say there are 4, and then mine is the 5th measure, and I put them, staple them all together in a packet, and I give that out to, let's say, couple thousand people. And then I look at the results, and what I'd like to see is that for each person, right, they all converge, all the 5 measures converge on the same finding. Let's say it's a measure of depression, just for simplicity's sake. I think that was the example I gave a second or two ago, right? Nelson measure of depression. Okay. So what we want to see is my measure of depression says, let's say for individual A, wow, this person is very depressed. I would want the other well-established measures to also agree. Yes, this person is very depressed. This person is very depressed, and so on. If mine didn't, if they all said the person's not depressed and mine said they're very depressed, I got a problem, right? My measure is not measuring what I think it's measuring. Right. So again, convergent, the degree to which measures of a similar thing, right, the same concept, all agree or all come to the same finding. Now, discriminant validity is where you have measures of different things, and right, it's the degree to which measures of different things do not agree. Discriminant validity. So if I have a measure of, let's say, depression, I want to give them a measure of, in my packet, a measure of happiness. Let's say anxiety, and did I say happiness? Happiness, maybe, and I don't know, maybe some other measure. Let's say excitement, or some other. Let's say, so we get a few different mood states. What we want is to have my measure not correlate with or not agree with other measures. So let's say that I get the correlation, the packets back, and mine says, "Oh, this person's really depressed," and then on the measure of happiness, it says they're also very happy. I've got a problem, right? It's not discriminating. It's not showing one particular mood state, which is what I want, right? I only want really one mood state out there. Okay. Now, internal validity, the simple way to define that I've defined this is, were your predictions correct? Are your predictions correct? Right? So that's the answer. We won't know the answer to that until we do the actual experiment. So internal validity is, are your predictions correct? Now, there are things that can torpedo your ability to answer that question. Like the first one is subject self-selection. Anytime you're doing an experiment where you don't randomly select and randomly assign people to groups, you've got that problem. And it's not good, right? It can basically, you're not going to be able to address the person's, whether or not they are anything in your experiment, actually, because you've got this subject problem. I'd like to talk about this example. An example of this would be, let's say you've got a couple fraternities, and you give and you say, I'm going to have expose one fraternity to this particular measure, and let's just stay with the mood thing for now on self-esteem, and another fraternity to a different mood, right? So one will make them all happy, and the other one will make them all, let's say, sad or angry. And then we're going to look at its effects on people's, like optimism for their future, right? And about their own personal future. And then let's find out, lo and behold, we get big differences. Now, normally we'd say, okay, the differences on the DV, right, the optimism scores for their personal future, is caused by the mood manipulation differences. Now, we normally say that, but because of the way that we did this experiment, we can't, because we've got a problem of subject self-selection. What that means is these people have already selected themselves into those two groups. Right? there could be a reason why people decided to join fraternity A and why people decided to join fraternity B. And that has nothing to do with my experiment, of course. But maybe those personality characteristics are what's driving their answers on the DV, right? Those personality differences. Like everybody in fraternity A has a certain type of personality, and people in fraternity B have a different type of personality, right? And that could be what's driving their differences between the two groups on the DV. It has nothing to do with your mood manipulation, right? So that's important to note. And a simple example of the subject self-selection. I always talk about another example is back in the 80s, people thought that there's some parents that thought that certain types of heavy metal music would cause people to kill themselves. There's actual lawsuits against Ozzy Osbourne, Judas Priest, a couple other people, and they were brought to the court. Got a lot of attention in the media, saying that in this case, their I think teenage sons had killed themselves, and they were listening to that music, or they listened to it a lot, and they sued the artists, saying, for example, in Ozzy's case, he has a song called "Suicide Solution," and he says that's about, in terms of a solution, like a chemical solution, right? To play on the word solution, right? That's a liquid, but also a solution to problems. But he's saying basically, the song is basically saying is how alcohol is a horrible thing and blah blah blah. And so, like I said, they were both. And so, but the basic claim that these parents are making is that the music causes people to want to kill themselves. That was the claim that they are making in the court case. Now, the reason I bring this up here in the subject of self-selection is that the parents were not considering that maybe these subjects had selected themselves into this group, that there's something else besides the music that is causing them to do this particular behavior, in this case, suicide. Right? Like, it could be the case that people who are prone to suicide are drawn to that kind of music. Right? Maybe that's the case. And just as a side note, both of the court cases were dismissed. They were sort of thrown out of the court. They were not. The parents did not win in that case. Now, if we wanted to look at their claim, not with regard to suicide, but let's say violence. If you had a theory that certain kinds of music causes people to be violent, like some people have said that about certain types of hip hop music or or any kind of music, we could do that with. We could look at that experimentally. You could let's say, 100,000 people selected, right? And we're gonna, let's say, we randomly assign. We'll have 5 groups of 20,000 each in these big arenas. So we randomly assign, and for the 100,000 people, right, they're all ages, all different types of walks of life, and they're all a very heterogeneous group. We put 20,000 people in Arena A, and we're going to have them listen to, Willie Nelson, and 20,000 in Arena B, have them listen to Metallica, and 20,000 in Arena C, Taylor Swift, and you get the idea, right? Different genres of music. Then we'll look at our dependent variable. So the independent variable is all these different types of music. The dependent variable would be amount of violence that maybe happens maybe during the concert, but especially also right after the concert. So out in the parking lot, is there any kind of violence happening? Vandalism, assaults, and so on. And so we find, as we would predict, that most of the violence happens right after a Justin Bieber concert. No, I'm just kidding. Or One Direction. Pretty much the same. But that actually is sort of, as kind of funny as it sounds, would be a nice, simple experiment to test whether or not violent music being exposed to a certain kind of music would cause people to be more prone to violence. Okay, moving on to another threat to internal validity. So again, just before we talk about this, it's super crucial, just coming back to A there, that the researchers randomly select and randomly assign people to conditions. Okay, now B, demand characteristics are aspects about the experiment that bias the way the subject responds. So, for example, of course, in prejudice research, one of the big ones is the race of the experimenter, right? It definitely has been shown to have a reactive effect on the subject. So you got to be aware of that. Other things like, for example, let's say the only room you could get to do your experiment has a one-way mirror, but that doesn't have anything to do with your experiment. And let's say that you leave, during the experiment, for whatever reason, let them have some time to fill out their questionnaire. What's the subject thinking about when you leave? They're totally thinking that, oh, they're watching me through that one-way mirror right now, right? And maybe they're going to get really nervous, and they start thinking, oh, man, oh. And so then that anxiety might affect how they respond on the DV, on the questionnaire, and then you got kind of junk for data, right? So you got to be aware of these things and sort of test them out before you actually start running the experiment to make sure that you don't have these experiment expectancy effects. Basically, what's happening here is this is the nonverbal, unintentional behavior of the experimenter that biases the subject's response. So, unintentional, nonverbal behavior of the experimenter biasing the subject response. Like the experimenter saying, let's say the subject has to choose two things on a little panel, and the experimenter is sitting there, and he or she knows what they want the subject to do, right? Because they know what condition they're in, and so they're hoping that they're going to choose whatever X, whatever it is. So the experimenter, of course, doesn't want to wreck his or her experiment, but they may unintentionally, right, sort of unconsciously, smile a little bit if the subject gets close to the one that the experimenter wants them to pick, or nod a little bit, right? And again, they're not consciously doing this. The subject is really, perceptive in a lot of ways and can pick that up. Well, there's looks like they're nodding a little bit or they're smiling when I go for this. So, and most subjects want to be good subjects, and so they want to do what they think the experimenter wants, so they pick that, and so then you got more problems. And the way to get around that is just to simply have research assistants do the experiment who don't know what the hypotheses are, and that way they can't introduce systematic bias into the experiment. Now let's come back to this issue of the artificiality of the lab, right? Generalizability. We've got this issue of generalizability. How can we generalize the results of our experiment to the real world? That's what we mean by generalizability. It's sort of interchangeably used with the term external validity. Same thing. How can we generalize our results to the world? That's what we're interested in, right? If I do an experiment that can only describe experiments or behavior in, room 234C, Bazzini Hall, CSU Turlock, it's meaningless, right? So we want that behavior to be generalized. Well, the way to get around this artificiality problem, right, that people know they're in an experiment, and maybe their behavior is not fully natural, is we've looked at things like what's called mundane realism, where you have the lab look like the real world setting that you want to generalize to. So if it's an office behavior, let's make the lab room look like a typical office. Now the idea is that the more that it looks like a real world setting, the more people will act naturally and behave that way. which is great, makes a lot of sense. The problem is a lot of labs are shared these days, and a lot of labs. So therefore, if I make this, I go through this expense and making it look like a normal cubicle, and I've got all this. It looks great, little partitions and computers and all. Then I have to schlep all that stuff out. Let's say at 9 o'clock, because another researcher needs to use the room, and then I gotta schlep it all back in there at 1 o'clock and reset it up because I have it for the room for 2 more hours, and bring it back out, and you can see the problem, right? So, and even besides that, it's a lot of time and money, and people don't have that to do that kind of thing. So instead, what we tend to do, rather than mundane realism, is we shoot for experimental realism. Some people call this psychological realism. And what we're aiming for here is to have the IV be as psychologically and emotionally engaging as possible. We want the IVs to really have pack a wallop, really have it be impactful and powerful. The idea here is that if the subject is really psychologically and emotionally engaged, they're not thinking about, oh, this is just an experiment. This isn't real life. And an example of this would be the Milgram obedience experiments that you may talk about in some of your other later classes in social psych. But basically, just in a nutshell, this is the sort of the ideal example of experimental realism. Another one, just as an aside note, is the Zimbardo prison study, which you may learn about a little later too. So what Milgram did was he had real people come to the lab at Yale, and they were told that, and they met this middle-aged guy who they were going to be giving shocks to via the shock machine. For every answer he got wrong on a memory test, and he was in the next room, but you could hear him, and they saw him getting strapped down and getting real shocks. It looked like a real thing. It buzzed and everything's machine that the subject did. But it was the subject who would be pushing these shock levers. Every time he got an answer wrong, it would go up 15 volts. And so every time he got, like I said, another answer wrong, it would go, say 70 volts, then 85 volts, then 100, and so on, all the way up to. The question is, do people go all the way to the 450 volts? Right? And this guy said, "Oh, I've got a heart condition. Is this gonna hurt me?" Or and then the experimenter like, "Oh, he'll be fine." And then what happens around, say, 75 volts is the guy's like, "Ouch, ow," and then right around 100 and 150, so this is starting to bother me. I don't want to do this, and is begging to be let out, and increasingly is screaming and so on. And then right around like in the mid 200s, screaming bloody murder, top of his lungs, and the experiment. Now the subject, if you're the subject, you're sitting there, right, and you're thinking, "Oh my God, I'm killing this guy," and the terrible experimenter won't let him go. And then it gets quiet, right? He doesn't answer, and the experimenter says, treat a non-answer like a wrong answer, and continue. And now you're like, and so you ask the question, there's no answer, and you hit the person with a 300 volts, let's say, and there's no answer. What are you thinking, right? You're thinking, "Oh my God, I killed this guy." Now, you're not thinking, "I wonder what's on TV tonight." Right? That is intense experimental realism. Now, it's not to say that we want all of our experiments to be that life and death, at maximal level of involvement. But that's a great example of, the sort of the ideal level of experimental realism. So it's, again, experimental realism, we want the person to really be engaged psychologically and emotionally. We don't want them to be distracted or bored or anything like that. And then so the more that they are engaged, the more natural their behavior will be. And it won't be artificial. Now, reliability. This is the degree to which our findings, right, your finding in your lab room, can be replicated or repeated by other researchers with, other subjects in other labs. So it's the degree to which your findings can be replicated or repeated by other researchers with other subjects in other labs. Okay. In terms of other research methods, actually, I'm going to skip past a bunch of this stuff because we don't really need to get into any of that detail. And I think you're all probably thinking this too right now. Yes, you may be excused. Your brain is full. So let's stop right here. I hope you enjoyed this discussion of research methods, and we will end it right here.